Hello and welcome.
I see we have Gamer Boy, Isra watching from Texas, Cambria, Rosalie, Ibrahim, Palmetto Gal, Rebecca, Cookie King.
Queen Donut, Paige. Oh, we got a good crew here, and I'm seeing lots of answers to our warm-up problem. The answer that I'm seeing the most was just to add, so 5 plus 4 plus 3, and then minus 2.
Ooh,
So
and what's the number we're trying to get to?
we're trying to get to 10.
And that gives us 10. I saw lots of good solutions in the chat. Hello to Isla from Texas, and Henry and Harrison.
That's right. I think John had come up with 2 times 4, and then plus 5 minus 3.
Ooh, that's a good one.
That is. And I know I saw a few others. I think I saw 5 minus 3, and then a times 4, and then a plus 2. That was another way of getting 10.
You're writing all over me, Math Dad.
You better watch out, Science Mom. I've got a pen and I know how to use it. So kudos to all those great solutions. I think we are warmed up and ready for today's activity. I'm going to throw a link up there on the screen so that you can see it, but also you'll see that link in the chat. Science Mom Amber's there helping to answer questions and pasting in that link.
It's in the video description as well. So if you're watching the replay, you can just click in that description to follow along with this activity. What are we learning about today, Math Dad?
We're talking all about ratios, Science Mom. So as you join this activity, you'll be picking a name for yourself. It can be your YouTube handle or some other made-up name if you'd rather. And you're going to join using that link. And when you do, we've got a warm-up activity asking us to balance some scales. And I actually see here, Science Mom has been hard at work trying to get the scales to balance.
I have. So this is a fun way for us to start learning about ratios. So I started out here with just 1 apple and 1 orange, and those scales aren't balanced.
Nope.
The apple weighs more than the orange. Well, what if I do 2 apples and 2 oranges? And if you have the Desmos activity, you can be playing along with this as well. I'm still not balanced. But if I increase my oranges one more time, now I am.
Totally.
3 oranges weighs as much as 2 apples.
That's pretty cool. You found it. And actually, there's a blue button there that lets us record that answer to the table.
Oh, I'm going to do it. I'm going to record it in the table. Let us know in the chat, if you have this open, can you find any other ratios where the oranges and the apples balance?
I bet there are some others, not just 3 and 2, but I bet there are some others that work. And that's our warm-up. I want to see how many we can find as a group. I'm guessing we will be successful.
Ooh, Bethany says 18 and 12.
Ooh.
Should I try it? I'm going to try it, Math Dad. I'm going to double check this. 18, that's a lot of oranges.
That is a lot of oranges.
Whoa. And 12 apples.
That's right.
It works.
Good
Nice job, Bethany.
Lynn has 12 oranges, 8 apples.
Ooh, let's try that one. 12 and 8. There we are. That one works too. Nice job, Aylin.
Good.
Answers are filling up the chat now.
So I'm seeing some wrong answers as well, and that's okay. You got to try things, right?
You do.
Kind of wiggling them back and forth because we don't know in advance. And ooh.
I'm going to try another one. I see 12 and 8. Is that the one? Oh, that's the one I just did. 8 and 4. Let's try 8 and 4.
Ooh, 8 and 4. It's an interesting try.
Not quite. What about
9 and 6 is one I'm seeing. So from Sarah. Sarah used 9 and 6.
All right, let's try 9 and 6. There we go.
Haha.
Am I going to be able to get balance with any number, Math Dad? Like if I just said, okay, I want to pick 3 oranges. Is it going to be, or 6 oranges, 5 oranges? Is it going to be possible to balance it with 5 oranges?
Only if you have a knife to slice up one of the apples, Science Mom. So in this case, the applet won't let you use fractions, but so in theory, there is a way to balance it, but you would fail on this particular one because
because I see with 4 apples, it's slightly heavier. With 3, it's slightly less.
Yeah, so we definitely have some limitations. There's some relationships, and that's what a ratio is. It's a way of comparing the different sizes of units. Because we're not just counting one fruit here, we're talking about the weight the units are of different sizes, kind of like centimeters and inches are units. If I say, ooh, my finger is 1 unit long, well, I didn't tell you if I was using inches or centimeters. Or my bank account. Oh, I have 7 in my bank account. Well, is it $7 or 7 cents? Not all units are the same size, and ratios are a perfect tool for comparing the size. So in this case, well, it was 3 oranges had the same weight as 2 apples.
So our ratio is 3 to 2?
3 to 2 is what we call that ratio. So we're going to move on to our next screen. So our first activity. So move over to screens 2 and 3. And what we see here is some numbers. We actually collected most of these. So 15 and 10 matched. 3 and 2, that was a balance. And 6 oranges, 4 apples was another way to balance. So I want you to fill this in. What do you notice and what do you wonder? And after you've answered this, I'm going to highlight maybe some good answers that I get. I want you to go to the next screen and work on it as well. So I'm going to give us about 3 minutes on this one.
What do you notice about these ratios and what do you wonder? Type it in.
My countdown is a light gray and it doesn't show up very well, does it?
No, it doesn't. Are we muted right now?
Nope.
We're not muted. I think you should have music with the countdown method. Like some light background music. That would be nice.
Ooh, that's a good idea. Do you want me to sing? Sorry.
I know what you're going to sing, and my answer is no.
The fruit is making me hungry.
If you've already recorded what you notice and what you wonder, be sure to go on and do number 3 as well. Work on screen 3 too. And there we are. That is time.
That's right. So 3 minutes is up, and we saw some great observations.
Oh, I love these observations, Math Dad. The McClendon family noticed that the apples are heavier than the oranges. Kylie noticed that the fruits are never the same amount. When it's balanced, you always have more oranges than apples.
Good
and
job.
Sonia and Ibrahim noticed that as well. And Isra noticed that there was a pattern and wondered if you could extrapolate. If you
Ooh.
could just pick a random number of oranges and then use math to predict how many apples.
Ooh, or maybe vice versa. If you could pick,
Yeah.
if you were given a number of apples, could you calculate the number of oranges that would make it balanced? Excellent question.
Van noticed that the apples were always even and the number of oranges was always odd when they were balanced.
Ooh, so that's interesting to see that relationship and see when it holds or if it's always true. That's a good question there. John noticed that one apple was the same as 1.5 oranges, so getting some fractions in there.
Awesome. And Anastasia noticed oranges are heavier than apples and wondered how many fruits until the scale breaks. I love that question, Anastasia. That's a good one.
I have a feeling that they're going to try to break the scales a little later in this activity, Science Mom. So excellent questions and lots of good speculations. And I'm seeing, like Celeste was like, what if we did 300,000 oranges and 200,000 apples?
Would that work?
Well, that is the question. Could the scale withstand it? I like it. So let's move to the next screen and see. So it asked us to come up with an additional pair. So another equivalent ratio. So 15 to 10, 3 to 2, 6 to 4. So were there other possible ratios? And
Whoa. Gamer Boy and Ellie, some of you have so much fruit on the scales, I'm amazed. But they're perfectly balanced.
Somehow they picked really large numbers. A few people picked more realistic numbers, like Sonia and Isra. But some of them were picked. There's so many zeros, I can't even see the full number. It doesn't even.
But the picture's
display.
fantastic because it's just fruit going up off the screen. It is so fun to see the work that you're submitting. I really enjoyed reading everyone's answers here.
Genuinely making me hungry. All right, so Science Mom, how would you go about adding something to this table?
Well, I noticed that the ratio stays the same, right?
Okay, so 6 to 4, 3 to 2, 15 to 10. And what do you mean it stays the same? What do you think?
I mean, so if I look at 3 to 2, if I times 3 by 2, and then I times 2 by 2, that gives me the next row of 6 to 4.
Oh, okay, so just a sec. I'm mousing over this 3. This row here, you're saying if you multiply this row by 2, each entry, you get the row below it?
Yes. So if I did 3 times 5, that's 15, this top row. And then if I do 2 times 5, that's 10, the top row. So if I just take this 3 to 2 ratio and then multiply it by another number, I can come up with another entry. And I'm going to take the first number that I see in the chat. So go ahead and give me a suggestion. Type your favorite number or whatever number you want me to use in the chat. And that will be the one I use to multiply.
0. Okay.
Okay.
Smart Alec.
Not 0, Rosalie. I can't do that one. James,
It does balance 0.
It
so
does.
I can't complain too much.
James says 11, so I'm going to do 33 and 22. Excellent choice, James. Although I do like the 0 answer too. That's funny. And it is balanced.
It is balanced at 0 and 0.
No fruit,
so
it's balanced.
Maybe I shouldn't complain. They're just good at outsmarting my expectations. So one interesting thing.
It worked.
It worked beautifully. I did see mentioned in the comments was that for the oranges, we're getting multiples of 3 every time. And for the apples, we're getting multiples of 2.
Ooh.
And that has everything to do with your observation, Science Mom, with the 3 to 2 ratio. So we can multiply both of those numbers by any value, and that will give us a new ratio.
Even the 900 trillion value that Paige put in the chat, could we even make ratios that big?
You can indeed make ratios that big. And in the grand scheme of things, that's not that big of a number. It's just a lot bigger than we're used to working with, because the numbers, they just keep going forever and ever.
That's probably bigger than the scale could handle.
That is true. There's not that many apples on Earth. So I really do like seeing the answers we're getting. We're going to go ahead and go on to yet another activity here. So screens 4 up through 7. I can do
So
this.
go ahead and click that next arrow and take yourself to screen 4.
All right, so now you get to select your own fruits. So we did oranges and apples already, but you can select any pair of fruits, and we're going to see if we can come up with new ratios. So what
Look at this. We have mangoes.
Okay, so mangoes and
Dragon fruit. I love it.
Ooh.
Mangoes and dragon fruit.
so mangoes balance with dragon fruits in a ratio of 5
Sorry.
to 7. Oh.
I wanted to change because I saw that we had pomegranates. And what is this?
Rambutan.
Rambutans! Pomegranates and rambutans. Oh, this is fun. I like that they have different fruit.
So they use a 1 to 8 ratio. No, Science Mom, you have to pick one, and we have to.
Okay, this is the last.
Science Mom gets excited when we start talking about fruit.
Lychees and avocados. And I won't change them again, Math Dad.
All right, so 35 to 4. So if you had a piece of paper, we could write out some possible ratios that work, and we can enter them in the table. You want to try it, Science Mom?
35 to 4. That means I need a lot of lychees for each avocado, right?
That's right. Lychees are much smaller.
So if I put in 35 and 4,
And you should hit check my work, and they balance.
they do. They balance.
Excellent.
Is it lychees or lychees?
That's a good question. I think lychees wasn't. We went to Hawaii one time, and they told us the right way to say it.
That's right. And we ate them, and we loved eating them, but now I don't remember. All right,
so-
I'm going to reset it, and now I need to try another ratio.
All right, so you're going to keep trying, Science Mom. The rest of the crew is going to dive in and do their own numbers. So I'm going to turn us off. I'm going to set a 5-minute timer. We'll go for at least 5 minutes on this one because there are 4 screens, and we'll see how far we can get in that amount of time. But play with it and see what you can come up with as far as balanced ratios.
Oh, I just wanted to see what it looked like if it was wrong. Look at that, Math Dad.
That's pretty wrong. Poor scale.
The lychees won. I see Nathaniel says unable to get on a computer because if you're watching on a phone, and that's okay. You can just, come back to the link later when you do have access to a computer and try it yourself.
That's right.
But the results here are amazing. Math Dad, did you know that Ibrahim balanced 18,000 strawberries and 18,000 lychees and 24,000 strawberries? That's a lot of fruit.
It sounds like a delicious balance to me. Okay, so look at these numbers. So pomegranates with oranges, what Science Mom went for here.
Yes, and I wondered, what if you could cut fruit in half? So I told the program here, I said I want 3 times 1.5 pomegranates, which gave me 4.5 pomegranates in total. And then for the oranges, to balance it, I knew I needed to keep that ratio of 3 to 5. So I said 5 times 1.5 oranges, which is 7.5 oranges. You ready to check it?
Let's check it.
Let us know in the chat. Do you think this is going to work? Will it balance? Yes or no?
Looks plausible to me. It's kind of weird seeing half of an orange in the graphic. I thought it was...
And half of a pomegranate?
Yeah.
Yunu says yes. We've got a couple other yeses coming in. Nathaniel Academy and James say yes. Let's try it. Boom, it worked.
It did indeed work. Okay, so Science Mom, this was interesting. So some people tried to break it with big numbers because they want lots of fruit. Science Mom and several of you tried to break it by using fractions. It still didn't break, so that's pretty cool. But this strategy you used here was interesting. So it was 3 to 5. We knew 3 and 5 would work. So a 3 to 5 ratio when we're talking about pomegranates to oranges. But you're saying as long as you multiply both of those numbers by the same value, it will work. So if I put a 3 times 7, I could also use 5 times 7, and you're saying that one would balance?
Yep, as long as I keep the number the same, it should work.
That is so cool. Some of you might even recognize that this is closely related to the ideas of fractions and simplifying fractions. So if I were to use a fraction 21 divided by 35, that would be the same as 3/5. And yeah, so that's not a coincidence. That's exactly how it works. And yeah, that's the relationship between these two. So we can scale both numbers of a ratio by the same value, and we'll get a new equivalent ratio.
Excellent.
So kudos to everybody who found it for their fruits, and so lots of different answers here. All right, on the next screen. So Ella knows that 15 grapes will balance with 1 dragon fruit. And then she says, well, 16 grapes should balance with 2 dragon fruits. Will that work? So let's see what we got here as our result. I had 0 students say that it will balance, and 19 students say will not balance.
Kudos, Rosalie, Aylin, Tommy and Serena, T, Gamerboy, Ellie, Kylie, Rachel.
Anastasia, yep.
Good job, everyone.
Seems like everybody got this one right. So why not? Because, look, I just added 1 of each fruit to eat both sides.
But you can't just add 1 fruit of each sides because the ratio says that 1, what are we working with? 1 grape is not equal to 1 dragon fruit. 1 dragon fruit weighs a lot more. And so this will not balance.
Excellent. Super interesting. Now, it's interesting to me that we could multiply on both sides by the same value.
We could. So if we wanted to add 1 more dragon fruit and we still wanted it to balance, how many grapes would we need to add?
15 additional grapes.
15 additional grapes. So we could have 30 grapes and 2 dragon fruit, and that would balance. But 16 grapes will not balance with 2 dragon fruits.
So ratios work well when you're multiplying both parts of the ratio, but when you're adding a number to both sides of the ratio,
you will break it.
It doesn't work. And with fractions, it's the same way. You can't just add something to the numerator and denominator, but you can multiply the numerator and denominator by the same value. Okay.
Are you ready for the next?
We're ready. Let's do it.
All right, our next question here, apricots and limes. The scale balances with a ratio of 10 apricots to 6 limes, and you need to select all of the equivalent ratios.
Okay, so Science Mom.
All right, help me out here, because I know that you all had a chance to look at this.
Okay, so 20 to 16.
Should I select 20 to 16?
It looks like very few voted for that one.
Nope, I'm seeing no, not 20 to 16. How about 50 to 30?
So yes, the chat is saying
Yes.
50 to 30 will work. And I noticed if you multiply both parts of the ratio by 5,
Then you can get 50. Yeah, because 10 times 5 is 50 and 6 times 5 is 30.
okay.
And 7 to 3, that is not going to work. But 5 to 3 does, because I can divide 10 by 2. That gives me 5. And I can divide 6 by 2. That gives me 3. So I did the same thing to both numbers to keep that ratio the same.
So division and multiplication play nicely with ratios.
That's right.
Okay.
Good job, everyone.
Yeah, seen lots of correct answers. The table here says that there are 2
you need
limes
to
per
open it?
5 lychees. No, not one,
yet.
one more. Now, Diani says 22 limes will balance with 55 lychees.
Lychees.
Lychees. What about 22 to 55? So will it actually work? Is Diani right? Will balance or won't balance? And what did we say here? I had 15 who said it will balance, 3 who said it won't, and 2 who are unsure. So let's
And
think,
it
Science
is,
Mom.
it is just fine to be unsure. That is an okay response. I think that if our ratio is 2 to 5, then I need to look at that 22 to 55 balance and think, okay, could I multiply something by 2 and 5 to get those numbers? And I can. I can multiply 11 times 2. That gives me 22. And I can multiply 11 times 5, and that gives me 55.
So 2 times 11 and 5 times 11.
That's right. So I'm going to say it will balance
Good job.
because the ratio stayed the same. I multiplied both sides by the same value.
Yep, that number 11. So yes, it will indeed balance. It's a lot easier when the scale's there and you can just throw the fruit on and check, but in real life we don't usually have that virtual scale to try it out on.
If they had grocery stores if they had scales at the grocery store that could measure anything like that, Math Dad, that would be pretty awesome.
That would be way awesome. All right, so let's go on to our next screen. So here on screen 8, we want to try to put it all together. Can we put into words an explanation of what a ratio is? So how can you create equivalent ratios after knowing one ratio? And by all means, if it helps, use an example, but try to explain to someone else. So if your brother or sister or your friend who's not watching this lesson, can you put it into words that they would understand? And to give you a couple of minutes to try.
So what's the question that we're supposed to put into our own words?
So
What's a ratio?
No, well, when you know a ratio, how can you create equivalent ratios that also will balance the scale?
Okay, so if you know that there's 10 to 12 in this ratio here for rambutans to apricots, how can you make a new ratio?
That's right.
Explain it like you would explain it to a friend or to someone else.
Attack. All right, we saw some great answers. I think my favorite came from Avery, who said, you can multiply both numbers of a first ratio by a fixed number and those numbers create an equivalent ratio that can also balance the scale. So that reminds me of your explanation. Several people did
Yeah, Stanley said multiply both numbers by the same number, and then if you multiply them both by the same number, it will create an equivalent ratio. Celeste, great way to explain this.
Merritt said you can double both numbers. Boom, new ratio that's equivalent.
Yeah, Amira said that too. If you just double them, then you'll have the same ratio.
You can triple them.
And Anastasia pointed out you can divide them both by 2. Cut them both in half, that will give you the same ratio.
Yeah, so you know what?
And John Hamilton summed it up really well. You have to do the same thing to both sides.
That's absolutely true when we're talking about multiplying or dividing,
Yes.
but not
No.
adding or subtracting.
Not with addition, that's right. If I add 3 to each side, then that's not going to balance anymore. But if I multiply 3 on both sides, then it will.
Excellent. All right. We are ready for our final 2 screens for the cool down.
Cool down time.
So one final problem for us to answer, just to solidify and see, do we really understand this? And then on the final screen, you get to tell us, how did you feel about learning today? And how did you feel about this idea of creating equivalent ratios when we were given a ratio? So take just a few minutes and work on that. On this one, so can you select all the combinations that will balance the scale with pineapples and mangoes?
I'm going to ask for some help in the chat on this one, Math Dad. Can I do that?
Give everyone a moment to look at it.
Okay. In like 30 to 60 seconds.
Okay.
Help me out.
Would you say these are your favorite fruits in all the world? Mangoes and pineapple?
I like mangoes and pineapple a lot, but my favorite fruit in the whole world is a papaya.
Oh, it's a papaya. Why was they thinking mango? That's right.
Mangoes were also good.
That's right. So when we were in Hawaii, there was this papaya tree growing, and every day Science Mom and I would go out for a little jog, and she would stare at this papaya up in this abandoned field, and one day she's like, I'm getting it, and she would get a ladder or a big pole or
No,
something.
I had a stick with a little net on the end, and the papaya was so ripe it was going to fall on the ground and nobody was going to eat it. It was in an abandoned little wild area. And so
Yeah.
I harvested the papaya, and Math Dad was terrified we'd get in big trouble.
That's right. Do you hear sirens in the distance? They're coming for you, Science Mom. Okay, so
All right.
three mangoes and 1 pineapple. Will it balance? Or, so we've got 5 options here. Which of these combinations will balance the scale? Help us out.
Nomad Academy says number 3 and number 1.
So 3 and 1
3 and 1.
definitely works. So
Yep, because I can divide 6 by 2, that ratio. I can divide each of them in half. That gives me 3 and 1.
good. So Bethany mentions 24 and 8.
Ooh, how would I get from 6 to 24?
You multiply by 4.
Multiply by 4, and then if I multiply 2 by 4, that gives me 8. Yeah, that one works well.
Good. And then
Any others?
I'm also seeing some Normand Academy 60 and 20. 60 mangoes, 20 pineapples.
Oh yes, because I can just times each of them by 2.
All right. And is anyone saying the other numbers?
These other ones, I don't think they work because, and I can prove it. You ready, Math Dad? I'm going
ready.
to prove it. So 2 pineapples, to get 6 pineapples, I just multiply by 3.
2 times
But
3 is 6.
But if I multiply 6 by 3, that gives me 18. 18 is not the same as 10.
No. 18.
Nope.
Good. And I actually like, so Paige and others kind of showed their work so that they didn't just give us the numbers, they even showed us how they calculated the numbers. So good job on your communication there.
Nicely done.
All right, so we got new equivalent ratios. And then how well did you understand the math in this lesson? And so to answer that question, let's look at what we were supposed to try to learn today. I can explain which operations create equivalent ratios. So what operations?
Multiplication and division.
So you can,
But not adding. If I just add numbers to a ratio, I'm not going to make a ratio that balances the scale, something that we would also call an equivalent ratio.
okay. Can you decide whether 2 ratios are equivalent? How's your equivalent ratio kung fu?
I'd say it's getting stronger.
Okay.
And it's especially strong if I have that nice little scale where I can test things over and over again.
And then can you create equivalent ratios and explain how you know that they're equivalent?
Yes. I just did it in the screen before by testing whether I could find numbers that I could multiply or divide to get them. So I'm going to mark this one here. And if equivalent ratios are new to you and you're feeling more like this, that's okay. You know what this means? If you're feeling like this or this means it would be good to go back through and try some of those exercises again.
That's right. It means there's more to learn.
Yes.
And Isra made an excellent observation, just saying, be careful when adding with ratios. You're going to get into trouble, but you multiplying and dividing will work.
That is right. And James has a great question here. What exactly is a ratio, Math Dad?
So a ratio is a comparison between two numbers, between two units. And I really actually like the apples versus oranges comparison at the beginning, because they weren't the same size. It took 3 oranges to equal the weight of two apples. So that we're using a different scale or units for the two things that we're measuring there. So ratios let us compare. And if you want to think of a ratio as a fraction, you're actually going to be just fine. There's no trouble to be found there. So often I'll just think of a ratio as a fraction, like 3 to 5.
3 to 2.
That's right. So
18,000 to 24,000.
That's right. All the big numbers that our crew has here. All right. Tomorrow we have another live stream, and this one there's going to be just a little bit of math, but it's mostly just going to be a fun live stream. There is an escape room.
That's right. And I'm hoping that you will give it a try so you can help guide me through, because I've not been through this escape room yet. I'm going to be trying it for the first time, and I could definitely use some hints and some tips on how to escape.
That's right. I'm actually going to go and get the URL because I want everyone to try it before class if possible, because it's going to be a lot of fun, but you'll be able to help Science Mom a lot better if you have tried it in advance. So let me...
That is right. John says, I love escape rooms. Awesome.
And this one's a tough one, so you'd better bring your A game if you think you're going to escape.
Normand Academy says we'll be here tomorrow. Yay!
Excellent. So I just pasted it in. Dive in, give it a try, show up tomorrow, and we'll see you can help Science Mom escape.
That's right. Thank you so much for joining us, Cookie King and Isra, Gamer Boy,
Normand Academy, Jen Thomas.
We hope that you have a wonderful rest of the day, and we will see you again tomorrow.
Work hard, grow smart. We'll see you next time.